Alright, we're going to be covering Chapter 7, Section 2, Solving Linear Systems by Substitution. We're still in Unit 8. So to give you a general idea of what we're going to be doing, I want you to look at these two equations over here and try to tell me what x equals. You may have been able to find out that x equals 2. Pretty much, if you saw that b is equal to 5, then you could plug in here b is 5 by using substitution. You know b is equal to 5, so you can substitute 5 in for b. Set it equal to 7. Then from here you could just see that this was equal to 2, or you could subtract 5 from both sides and get x is equal to 2. So this is the very basic form of substitution. What we're going to be doing is using equations, and we're going to substitute one equation in for another variable that we know that that equation is equal to, and it will make more sense as we go. We only have one vocabulary word for this section. It's the same as the section before. It's system of linear equations, and these consist of two or more linear equations in the same variable. And here's another example, just two equations that have the same variables. So both of these have the variables x and y, x and y. Okay, here are the steps in solving a linear system using the substitution method. I'm going to give you time to pause the video so you can copy these down in your notes if you don't have them already. Okay, our first step is to solve for a variable. Solve one of the equations for one of its variables. When possible, solve for a variable that has a coefficient of 1 or negative 1. So pretty much we're going to solve for y or x or whatever variables we have. And for example, if we had x minus 2y equals 8 and we wanted to solve for one of our variables, we want to look for one that has a coefficient of 1 or negative 1. So looking at the coefficients is the number in front of the variable. So in front of my y, I see I have negative 2. In front of my x, I don't have a number, but you could think of this as 1x. So I have 1x minus 2y, and I have equals 8. So I'm going to solve for this coefficient. I'm going to solve for this variable x because it has a coefficient of 1. So to solve for x, I would want to get rid of this minus 2x, and I would do that by adding 2y to both sides. Okay, when I add 2y here, this will cancel out, and I would get left with x equals 8 plus 2y, which is what I have over here. The next step is to substitute. You're going to substitute the expression from step 1 into the other equation and solve for the other variable. Workflow is substitute, distribute, combine like terms, and then solve. And we're going to work some examples so you can see more of this, but I just wanted to read these to you. Plug back in step 3, substitute the value from step 2 into the revised equation from step 1 and solve for the other variable. And the last step is to check your answer. Plug in the solution back into both original equations to check answers. Both equations should hold true. And like I said, you'll see these steps as we work examples. Okay, so let's look at our first example. We're given two equations. Our variables are x and y, and we want to solve this system of linear equations by substitution. So our step 1 is to solve for x or y or x, coefficient of 1 or negative 1. So I'm going to look at all my coefficients here. And I see I have coefficient of negative 2, 6, 4, and this one doesn't have a coefficient, but like we had said before, if it doesn't have one, you can think of it as 1, so 1x minus 2y. So I'm going to solve for that variable. In that first equation, I'm going to solve for x. So to do this, to cancel out or to move this negative 2y to the other side, I would add 2y to both sides. Okay, so rewriting what I'm left with, this would cancel out here. Now I'd get left with x equals negative 6 plus 2y. Okay, so we're done with step 1. We just solved for y or x. So now let's move to step 2. We're going to substitute into the other equation. So this is my revised equation from step 1. I solved for x, and now since I know x is equal to negative 6 plus 2y, I'm going to substitute that in for x. So what that means is for this x, I'm going to substitute in what x is equal to, which is negative 6 plus 2y. So negative 6 plus 2y. Okay, now we just did our substitution step. Next thing is to distribute. You see how we had 4x right here? So this 4 has to be multiplied by x, which is this equation here, so we need to distribute that 4 to both terms. Okay, so when I multiply 4 times negative 6, I get negative 24. When I multiply 4 times positive 2y, I get plus 8y. Okay, the rest of the equation here just comes down. So I have plus 6y equals 4. Okay, so I just distributed. Done. Okay, the next thing is combine like terms. Okay, so I'm going to look for my terms that are alike. So I have 8y plus 6y. So I'm going to combine those two. So 8y plus 6y is going to give me 14y. And I still have this minus 24. And then this is equal to 4. Okay, I just combine like terms, so now I just need to solve this. So to solve this, I want to cancel out this minus 24 by adding 24. So I'm going to add 24 to both sides. Okay, that's going to cancel this out. I'm going to get left with this 14y is equal to 4 plus 24 gives me 28. Next step here is to divide by 14 to cancel out this y that's being multiplied by 14. I'm going to cancel out this 14 by dividing by 14. Okay, so that cancels out this 14, and I get left with y equals 28 divided by 14, so that equals 2. Okay, so that was step 2. I substituted in the other equation, went through all the steps in step 2, and I got my solution of y equals 2. So now step 3, it says plug answer back into the original equation from step 1 to solve for other variable. So you know from step 1 we had this revised equation here, x equals negative 6 plus 2y. So now we're going to substitute in 2 for y. So instead of y, we're going to put what we found y was equal to, which was 2. So right here we're going to plug in 2 instead of y. We're going to plug in 2. And now we're going to solve this for x. So I have x equals negative 6. 2 times 2 is going to give me a positive 4. So negative 6 plus 4, I get x is equal to negative 2. Okay, so I just found my solution. I found my x value, which is negative 2. And I found my y value, which was equal to 2. Okay, so now we can jump to step 4 to check this answer. So to check this answer, we're going to take the original equations and we're going to plug in what we found for x and y. So for x and y we had x was negative 2 and y was 2. So we're going to plug these in to our equations. So I have x minus 2y, so my x is negative 2, minus 2y, which y is 2. The bottom equation I had 4x plus 6y, which y is equal to 2. So now I'm going to see if these both are true statements. So I have negative 2. Negative 2 times 2 is going to give me negative 4. And this is supposed to equal negative 6. So checking this, negative 2 minus 4, yeah, that does equal negative 6. So that is true. This bottom equation, 4 times negative 2 is going to give me negative 8. plus 6 times 2 is going to give me 12. Okay, so I want to see if this does in fact equal 4. So if I take -8 and add 12, yeah, that does equal 4. So this is true. So I saw both my equations do hold true plugging in my point. So this answer is correct. Okay, so next I want to talk about three possible outcomes that will happen in step 2 when you substitute, distribute, combine like terms, and solve. So I have 3 different equations here, and I went ahead and solved for one of the variables in each one, and we're going to jump right into substitution. So right here in this first one, I'm going to substitute in for y what y is equal to, which is 3x plus 4. So into this equation, I'm going to substitute 3x plus 4 for y. Okay. And when I do this, I get this big equation, so that was my substitute step. So now I need to distribute. In this particular equation, we had minus y, so this minus sign here needs to be distributed to both terms. You could think of this as a -1. Okay, so positive 3x times -1 will get me minus 3x. Here, I just brought down the 2x. This would give me minus 3x. If I distribute the negative to that 4, it would give me -4. This is equal to 6. Next step is to combine like terms. So I see here that I have 2x minus 3x. So that would just give me -x. I still have here minus 4 equals 6. Okay, next step, I just combine like terms. I need to just solve this equation here. So this -x minus 4 equals 6. I need to solve for x. So I want to begin by getting rid of this 4. So I'm going to add 4 to both sides. This -4 minus 4, I'm going to add 4 to get rid of it. So if I add 4 to both sides, I would get rid of that. I would get left with -x equals 6 plus 4 will give me 10. Okay, the last step to get rid of this negative here in front of the x, you can think of this as -1x, is to divide by -1. If I divide by -1, it'll cancel out the negative in front of the x. Okay, so that would cancel out. I would get left with x equals 10 divided by -1 will just give me -10. Okay, so this is one possibility. We'll substitute in step 2, distribute, combine like terms, solve, and we will get that our variable equals a number. Okay, so that's our first possible outcome. Let's look at our second outcome. Okay, so this is another equation. I solved it for x already, so we're going to substitute this in for x. Okay, so here I'm going to substitute in for x. X equals -2 divided by 3 x, or I'm sorry, y, plus 5. Okay, so that was my substitute step. Now I need to distribute. Okay, so if I distribute here, 3 times -2 over 3 is going to give me -2y. Okay, I would just go ahead and write this out so you can see. If you have 3 over 1 and you're multiplying it times -2 over 3, this would give you would just multiply straight across. So 3 times -2 would give you -6. 1 times 3 will give you 3. Okay, so -6 divided by 3 will give you -2y. Alright, so then distributing 3 times 5 will give you positive 15. Okay, the rest of this equation here will just come down. I have plus 2y equals 2. Okay, so distributing is done. Now I need to combine like terms. So I have right here minus 2y plus 2y. So if I have minus 2 plus 2, they're actually just going to cancel each other out. And what I'm left with is this 15 equals 2. Okay, we all know that 15 does not equal 2. So this is another possibility. We'll get that our two numbers that we get down to, they're not equal to each other. So this is not a true statement. So this is our second possibility. Let's look at our third outcome that we may get. So we may two separate equations. I already solved for one variable, so we're just gonna, just like before, jump straight into the substitution. So for y, I'm gonna plug in x plus 3 because that's what y is equal to. So right here, x plus 3. Okay, so that was the substitution step. Next I need to distribute. Okay, so I'm going to distribute this negative 2 to the x and the negative 2 to the 3. This 2x here just comes down, so I have 2x. Negative 2 times x is going to give me minus 2x. Negative 2 times 3 is going to give me negative 6. And then this right here is equal to negative 6. Alright, next step is to combine like terms. So I have right here 2x minus 2x. So these are actually going to cancel each other out. And what I'm left with is negative 6 equals negative 6, which is true. Negative 6 does equal negative 6. So this is the third possible outcome. In the second or third outcome, the variable gets canceled out and we actually didn't solve for a variable. So let's talk about what all three of these mean. So if you do solve for a variable, for example x equals negative 10, that means that these lines intersect. They intersect at one point and we have one solution. Once we find out what x equals, we can plug that back in and we can find out what y equals. For example here, if we plugged in negative 10 for x, go ahead and write that. That would give us negative 30. And then if we add 4 here, we'll get negative 30 plus 4. We would get y equals negative 26. So we would get a solution. We would get x is equal to negative 10 and y would equal negative 26. These would be intersecting lines that would intersect at this point. Okay, our second outcome is if we used our substitution and we got that two numbers were not equal to each other. That means that we have parallel lines. That means that these two equations have the same slope. They will never cross, so there is no solution. No solution. So if you get two numbers that don't equal each other, that means your lines are parallel. There's no solution. Alright, our third possibility is if we get two numbers that are in fact equal to each other as our solution. That means that we have lines that coincide. It means that they're the same line, there's many solutions, and like we've said as I said in the video before this, 7.1, any real number. So any number we plug in for x in both these equations, we'll get the same value for y if we solved it. So for example, right here, if I plugged in 0 for x, let's say I plugged in 0 for x, that means this term would disappear. And I would get negative 2y equals negative 6. So this is if I plugged in 0 for x. Okay, I'll divide both these sides by negative 2 to solve for y. Negative 6 divided by negative 2, that would give me 3. So I'd get y is equal to 3. Okay, I can check if I would get this same solution if I plugged in 0 for x in this equation. If I plugged in 0 for x here, 0 plus 3, yeah, y would equal 3. So any number I plug in here for x in both these equations, I'll get the same value for y. So that's why we have many different solutions, because these are actually the same line. So they intersect at a bunch of different points. So any real number could be our solution. Alright, so let's look at example 2. We have another system of linear equations and we're going to solve it by using substitution. So our step 1 is to solve for y or x, and we want to try to solve for a variable that has a coefficient of 1 or negative 1. So if I look at each of these coefficients, I have 2, 2, negative 4, and this negative y, you could think of this as negative 1y. Negative 1y. Okay, so I'm going to solve for that y in that first equation. So if I want to, first I'm going to rewrite this equation down here below. So we have 2x minus y equals 6. And I'm going to solve for y. So if I want to get rid of this 2x, which is a positive 2x, I need to subtract 2x from both sides. So I'm going to subtract 2x from both sides. Okay, this term is going to get canceled out because I just subtracted it. Okay, I'm left with negative y equals 6 minus 2x. Okay, next I want to get rid of this negative. You can think of this as negative 1y. So to get rid of that negative 1, I need to divide by negative 1. So I'm going to divide everything by negative 1. Okay, that's going to cancel out that negative. I'm left with y equals 6 divided by negative 1 is going to give me negative 6. Negative 2x divided by negative 1 is going to give me positive 2x. Because of the double negative, turn positive. Alright, so now that I have my equation, I can use substitution. I know y is equal to this right here. So this is what we're going to use to substitute into our second equation. So let's go into step 2. Like I said, for step 2, we're going to use substitution. We know y is equal to negative 6 plus 2x. So instead of y in our second equation, we're going to substitute what we know y is equal to, which is negative 6 plus 2x. Okay, so now that was our substitution step. We need to distribute next. So next I'm going to distribute this 2 to the negative 6 and the 2 to the 2x. So 2 times negative 6 is going to give me negative 12. 2 times 2x is going to give me positive 4x. Okay, the rest of this here just comes down. So I have minus 4x equals 6. So minus 4x equals 6. Okay, now solving this, next step is to combine like terms. And right here I see I have plus 4x and minus 4x. So those terms are actually going to cancel each other out. And I'm going to get left with negative 12 equals 6. And we know that negative 12 does not equal 6, so this is not a true statement. So like we said before, if we run into this situation, that means that our lines are actually parallel and they don't intersect, so we have no solution. So for this we would write no solution. And we could even write parallel lines. Okay, I'm going to go ahead and actually solve this second equation so you can see that our lines are in fact parallel. So I'm going to solve the second equation for y. So I have 2y minus 4x equals 6. Okay, so if I want to solve for y, I want to move this 4x to the other side, and if it's negative 4x or minus 4x, I'm going to add 4x to both sides. Okay, that's going to cancel this term out. I'm left with 2y equals 6 plus 4x. Next step is to divide by 2. That will cancel out this 2, and I'm left with y equals 6 divided by 2 is 3 plus 4x divided by 2 will give me 2x. Okay, so these are both my equations. I'm going to go ahead and flip or switch these terms here. So they're in the form y equals mx plus b, slope-intercept form. So rewriting this equation here, I would have y equals 2x minus 6. In this equation here, I would have y equals 2x, and then this number right here is a positive 3, plus 3. Okay, so looking at these two equations, yeah, they are parallel. They have the same slope and different y-intercepts. So they are parallel, no solution. Okay, in this third example, we have another system of linear equations. We're going to solve by using substitution. So looking at step 1, solve for y or x, coefficient of 1 or negative 1. This is already solved for y. Okay, so from here we could just jump straight into step 2. We're going to plug in what we know y is equal to right here. So for y, we're going to plug in negative 4 plus x. Okay, so that was our substitution step. So next we're going to distribute. So we're going to distribute this negative sign here. You can think of this as negative 1. So I'm going to distribute it to both terms inside the parentheses. So I'm going to have x. This negative 1 times negative 4 is going to turn into plus 4. And then negative 1 times x is going to turn into minus x. And we're going to get equals 4. Okay, next, that was our distributing step. Next, we have to combine like terms. So if I look here, I have a positive x and a negative x. So they're actually going to cancel each other out. Okay, and I'm going to be left with 4 equals 4. Okay, for this situation, if we get a number equals itself, that means that our lines, our equations coincide. So would say that there's many solutions or any real number. And remember that any real number part means that any number you plug in for x and you solve for y, you'll get the same value for y in both equations. In this fourth example, we have another system of linear equations we're going to solve using substitution, so let's jump right in. First step is to solve for y or x, coefficient of 1 or negative 1. If we look at both of these, they're actually both already solved for y. So step 1 is already done. We can use either equation, substituting it in for the other. But let's go ahead and pick this top one. We're going to substitute this in for y, which it actually wouldn't matter. You would get the same equation either way. Okay, so that was our substituting step, substitution. So now we need to distribute. But we actually don't really need to distribute. You could think of this as a 1 in front, and if we did distribute that in, this would just stay the same. 1 times 3x would still be 3x. And 1 times negative 8 would still be negative 8. So if you don't have anything in front of the parentheses, you can go ahead and drop the parentheses and leave it the same. Okay, this other part of the equation just comes down. Equals negative 2 plus x. Okay, so now we don't necessarily combine like terms, or we don't because they're not on the same side of the equal sign. Now instead of combining like terms, we just jump into solving. So instead of combining like terms, we just need to solve this now. So we know if we have variables, or the same variable on different sides of the equal sign, the way we get rid of one of them on one side. So I usually like to do the smaller one. This is 3x, this is just 1x. So to get rid of this x here, I need to subtract 1x from both sides. Or just subtract x. Okay, that will cancel it out from over here on the right side. On the left side, 3x minus x will leave me 2x. I still have minus 8 here. And then equals, and I still have this negative 2. Okay, now I'm still trying to solve for x, so I'm going to get rid of this negative 8 by adding 8 to both sides. Okay, that's going to cancel out that negative 8, and I'm left with 2x. Negative 2 plus 8 is going to give me positive 6. Next step from here is to divide by 2. That will cancel out these 2's here, and I get left with x equals 6 divided by 2 will give me 3. Okay, I found one of my solutions, so I can jump to step 3 now. I'm going to plug this into one of my equations to solve for y. Okay, so going to step 3, since these are both solved for y already, I can actually pick either one. So let's go ahead and do it for both. So for x, I found out x was equal to 3, so for x I'm going to plug in 3 for both of these. Okay, for this top equation I have 3 times 3, which equals 9, then minus 8. So for this one I'm going to get y is equal to 9 minus 8, I get 1. On this bottom equation I have negative 2 plus 3, so negative 2 plus 3, that is also equal to 1. So it didn't matter which one I picked, they would both give me the same answer of y equals 1. Okay, so my solution, my x was 3, and my y was 1. And like I said, since these lines are not lines that coincide, this is a single solution because these are intersecting lines. Okay, so now to check our solution, we're going to plug this point back into the original equation. So we had y equals 3x minus 8 and y equals negative 2 plus x. So let me go ahead and write my point down here. It was 3, comma 1 was our solution. So for x I'm going to plug in 3, for y I'm going to plug in 1. So these are both y equals, so 1 equals, and my x was 3. So checking my answer right here, I still have 9 minus 8, and yes, that's equal to 1. And over here I have negative 2 plus 3, and yeah, that's equal to 1. So both these check out. This is the correct answer.